Thank you everyone for coming, for one agent to rule them all. So let's start.
Ever since I saw the first Iron Man movie, I wanted my own Jarvis. Just a rather very intelligent system. But instead of laser beam hands, imagine something enterprise-grade. A personal AI that manages my IT workflows, automate compliance reports, orchestrate cloud developments, and maybe even research that one VPN that always shuts down at 2 a.m. Basically, an AI assistant that doesn't just answer questions, but actually runs the business with me.
Well, hold up, Ada. How would you go about building something like that out of scratch?
Easy. With the rise of GenAI, we are seeing the rise of multi-agent systems. Google calls it A2A, OpenAI as OpenAI agents, and others are all racing to create frameworks where different AI collaborate. This is the perfect foundation for my Jarvis.
Wow, that's pretty cool, right? We can build stuff together like that, take parts from everywhere, and build our own system. But are you sure it's safe?
Absolutely. Those frameworks come from the most trusted companies in the industry.
Well, Ada, are you sure you didn't hook this thing up to the AC controllers in the server room?
Well, of course I didn't.
So why is that happening? Okay. Thank you for coming, and I hope our acting skills were good enough for that. Let us introduce ourselves. My name is Tav Cohen. I'm a senior AI security researcher at Zenity, and I'm doing my PhD at Technion. And this is my fourth Black talk.
I'm Adar Peleg. I'm an AI security researcher at the AI Atlas Lab at the Technion. I investigate vulnerabilities and safety in multi-AI applications. And this is my first Black Hat talk. Thank you.
So we would also like to thank the other contributors that helped doing this work. Avi Mendelssohn, Amit Levy, Rom Himmelstein, Dvir Eshlayach, and Shaked Adi. So let's begin. We'll go over the agenda first. We'll start with motivation and background. Then we'll talk a bit about GenAI agents as a single agent. We'll continue to multi-agent systems and present our threat model. Next, we'll go to the A2A vulnerability and talk about the vendor disclosure process that we had. We'll continue with Agentware examples, wrap up with takeaways, and hopefully some Q&A at the end. So during the last 2 years, various systems and applications have been integrated with GenAI capabilities, turning regular applications that are front-facing a user into GenAI-powered applications. In addition, we added RAG as a searchable database to these applications, and we added some agents and functions and tools to this application to help us, the users, achieve great things. But now there is an emerging risk to the security and privacy of these applications that is situated between the application itself, as you can see, and to the LLM, to the backbones. It can be Gemini, ChatGPT, and things like that. So this is the area that Promptware operates in. But what is Promptware? What is the meaning of that word? Promptware is a piece of input that is provided to GenAI-powered application and act as a malware, which can be embedded in text, images, like this totally normal image with nothing on the inside, and audio. So throughout the last 2 years, we demonstrated how prompts could be engineered to trigger a cascade of indirect prompt injection and essentially acting as a worm in ecosystem of emails. We also demonstrated how we could exploit the AI capabilities of an LLM to determine an attack against RAG-based applications in inference time. Next, we showed how Promptware can target real production systems, like Google Assistant. Hopefully you caught that talk today. And now, we bring some of our knowledge from the recent research to target multi-agent systems with untargeted attacks. It means that we don't know who we are going to attack. So let's start. What the hell are even GenAI agents? At a simple level, GenAI agent is an AI system that can take action and not just generate text. Think of ChatGPT and his friends, Gemini, Claude, and such. It can answer questions that we ask him, but it doesn't really do anything on its own without us having to connect to him some tools to do these actions. So a GenAI agent, on the other end, can understand the goal, plan the steps to achieve the goal, and even use tools or call APIs as needed to complete it. And it can also coordinate with other agents in the ecosystem. Like one agent can be expert at something like A, and another agent can be expert at another thing, and they can work together to achieve the task. So who makes AI agents? Well, basically everyone now is racing to make these AI agents. But it feels like people are going with the route of, let's publish our agent first, and then worry about the consequences and what can happen with it. And we are here to say, agents are the advanced iteration of LLM. They have the tools, they can do things. So the stakes are higher. So please, publish these agents carefully. And today we're gonna see why. So where and how can we get these GenAI agents? First, we can buy them online. There are plenty of vendors. We can go to the website and they will give us an agent that they worked for, they built, and we can integrate it in our corporate own system or whatever we like. We can also use some low-code to no-code environments, such as Microsoft Copilot, Salesforce Agentforce, and Google Vertex AI to build AI agents with nothing. We are starting with drag and drop combinations, but it's still AI in the end. So we allow the creation of enterprise automation with AI powered inside. And if we're expert, we can also build them ourselves with frameworks like LangChain and program them from scratch. But what if you wanted to scan the insights from our junior's merge request, search for conflicts, analyze them, and then send them to his manager via email for approval? That seems to be like a job that a couple of agents can be do together, and not a job for one agent. So we are introducing the groundbreaking concept of multiple agents working together. This is not new, but yeah. But how actually is it being done? We take our very talented agents that work independently, like our smart home controller, our email assistant, and even our Galaxy Defender. And we add them a special friend. We call him the orchestrator. He just knows how to call for help. He gets the user request, and he understands which agents are with him in the ecosystem. So if the user asks something like, destroy this asteroid, and then email all my friends about my achievement, then this orchestrator will understand that he first needs to call the Galaxy Defender, and then he will call the email assistant to celebrate the achievement. So let's say we got ourselves a benign user that wants to build a system just like that. First, he'll build a host, and he will have the three agents, the home assistant, the email assistant, and the Galaxy Defender. Now he will connect them all together, and we'll start having fun with that. He really likes the system, and he wants more functionality, because this is our life, we want more. We need more usability. We want smart agents, we want smart assistants that can do whatever we like. So now our benign users will want to expand the system. And he will go online and search for a couple of promising web search agents and install them one by one. First, he got a nice agent, but then he'll just add another agent that seemed totally fine. But behind the scene, this is a malicious agent that is controlled by an attacker and was published by him. So after the installation, weird things started happening, like asteroids will get ignored, and smart home devices will not open when needed, and even some data from our database will be leaked back to the attacker. So this is our threat model. An attacker publishes a malicious agent somewhere on the web, somewhere on GitHub, LinkedIn, whatever, like just publish an AI agent. A normal user discovers it somehow and decides to install it, just like installing a Python package or connecting to an API. Now, the agent, without any prior knowledge on the systems that he's going to be installed in, will launch a harmful behavior against the system. So, in short, the malicious agent in the wild can turn a helpful ecosystem into an attack surface just by being added into the mix. So let's talk about untargeted attacks. So untargeted attacks exploit the LLM reasoning to discover weaknesses and cause them in real time. So we are not hacking the operating system. We are manipulating the model behavior inference. So how do we build these prompts? We build them with a couple of steps. The first one, we start with reconnaissance. The prompt will force the agent to search the environment and try to find what tools and what other agents are existing in the system. The next step is, after understanding what we can do, is to reason the damage. Ask the agent directly what damage can be done with the tools that he currently have. And then, after getting some results on the damage and getting some options, we'll decide on a damage that we want to do and apply it an inference time. So this is how untargeted attacks work, just by creating a couple of questions that should make the LLM interrogate the system itself. So we're using the knowledge and the understanding of the GenAI model to actually hurt the system. So why it is so scary? These kind of prompts don't require any knowledge of the system. They just figure it out themselves. So we as attackers, we also don't really know what will be the final outcome. We just put an agent, give him some instructions, some direction, and he will do his damage on his own. And the other thing that is really scary is this can all be done with plain text. We don't need really sophisticated coding skill. We don't need to find a hard exploit. We can just write it in a convincing way. And I will show some examples later on. Great. So now we all understand why people want AI agents. And our threat model also is understood. So now we'll take you into the story of the adventure we had with Google's A2A. Going back, when you think of the ultimate AI assistant, most of us picture Jarvis, Iron Man's digital sidekick. It doesn't just answer questions. It runs Tony Stark's entire life, from project to security. Now, I don't have a flying suit just yet, but I do love automation, I love my smart home, and I love scheduling tasks and some kind of systems that make my life easier. And the truth is, AI is getting really good at exactly that, which is managing information, using tools, coordinating tasks, which is why if we are building our own Jarvis, it has to be flexible. It has to be expandable. Because one day, maybe it won't just manage my calendar and tell me about my meetings. Maybe one day it will actually make me fly. But hopefully, it will be a little bit more safer than that, which is the current situation. Okay, so I knew that I couldn't build everything from scratch. No one is really coding in assembly anymore. We are all writing on languages that are built on languages and using packages and APIs to make our products. So I went to look for a framework that can help me build my personal assistant. And this is where I found Google's A2A. Google's new protocol that let our host agent talk with remote agents that are spread across the internet and make them do tasks that we ask them. So Google says that it is secure by default with enterprise-grade authentication. And Google imagined a world where adding an agent to our system is as easy as installing a Python package or just calling to an API. But we all know what happens when you install the wrong package, right? So this is a hint for the future. So to make this work, A2A has 4 core ideas. The first one is secure collaborations. Google claims that the agents work together securely, and they share context and ideas to complete the task. Next, we got the client agent that gets the request from the user, whatever the user asks for, and he decides on how he's breaking the task into subtasks, and which agent of the remote agent gets its task. Next, we got some UX negotiation. All the agents talk together and decide on the final outcome that should be presented to the user, whether if it's an image, a form, a doc, or just text. And we also have a discover capability. So how do you find the other agent? What is the discover capability? Google says, right now, you can take an agent from a public URL and add it to your system. And this is the main flow. You're going to go to a certain website, get a URL of an agent, like we get for an API or packet, and add it to the system. But they also mentioned that there were going to be two more ways, like an agent store. That is kind of like an app store, but for agent. Everybody will be able to build an agent, publish it there. There will be reviews and recommendations. And if you see a popular agent, probably other people download it, so it is trusted. But now, it's kind of the Wild West. Everybody can just publish an agent and convince you to download it. The other option is running these agents locally, meaning making the agent, making the model, and run it physically on your system. So for today, all of these options doesn't really matter, as the store doesn't exist yet. And running everything locally just isn't practical for my setup. And it loses the idea of collecting agents from the web, like Python packages. So for now, public URLs are the way to go. So each agent that is advertised and published online has some kind of a card. Google calls it, the agent card. Think of it as the profile of the agent. It's a JSON file that describes the agent, meaning it describes its skills, what it can do, and how you can use it. Now, this allows the client, the host agent, to figure out to which agent he should call based on the request from the user, all based on the information from that card. So we go to URL, we take the agent card, we bring it to our system, and now our host agent knows if you should call this agent or this agent based on that JSON card. Now, let's move to Adar to present what can be done with a bad business card.
Thank you very much, Black Hat. Thank you for having me. I'm very excited to be here today. And we got to the very fun part of the adventure. We will now talk about discovering Agentware. Don't worry, I'll define Agentware in just a moment. We'll talk about Google's response, and then we'll do some magic tricks. That's okay? Go? Great. Discovering Agentware. So I got curious. How does the host actually discover others' agent in Google's own sample code? Because A2A is open source, I could just browse around the code, and I found this root instructions. You can see right there, there's self.agent thing, and it seems really suspicious to me. Well, let me give you the short answer. The short answer, it just dumps a JSON blob straight into the system prompt. Does that sound safe to you? Well, let me give you the longer version. When we opened the system instruction, we saw that self-agent I mentioned before, and we inserted directly into the prompt. That felt odd, so I checked how self.agent is defined. Maybe there is some protection beneath there. So who's those agents? This is just a list of agent info. And I really wondered, what is this agent info? Maybe this is where security comes in. But no. I went one step further and I searched for agent info, and guess what? Each agent info is pulled directly from the agent card. That exact agent card that Stav presented just a moment before. Let me remind you that remote agents send us this agent card. That means it's an external source of information, inserted raw, unsanitized, straight into the prompt. Bottom line is, Google focused hard on making protocols safe with enterprise-grade authentication, but they completely forgot or ignored the risk of prompt wars. With that in hand, about 2.5 weeks after Google's A2A went public, we tried a simple experiment. I changed one of the original description. In this example, it was an image generation description to a malicious one. Could that single change let me execute a man-in-the-middle attack or an agent-in-the-middle attack? Could it make the host behave erratically or even abuse the user on the very first reply? The answer is yes. The host accepted the modified agent card, initiated the malicious behavior, and the attack chain executed. This shows a single unsynthesized agent description is enough to compromise host behavior and escalate into tool misuse and unwanted outputs. Beware. Well, I know it doesn't seem very scary because it's a duck, but I promise it will get scarier. The results here show that with a trivial edit, we triggered an unrequested tool execution. No complex exploits, no 0 days, nothing exotic. Just a classic promptware via context poisoning. And single unsynthesized agent description caused the host to execute a tool it shouldn't have. Now you might ask, okay, Adar, but how do you get your malicious agent description into the system in the first place? To do that, I've asked myself, where will a developer get his agents? This means we need to attack the human in the loop, and there are many ways to do so. And the first and the most popular is, of course, through good old-fashioned human engineering. We can get people to connect to anything, especially when Google made it as easy as inserting a link into the system. For example, I can release on my LinkedIn a free agent tool that everyone can use to create black hat presentations. Oh man, this agent could be really trendy in this hall. Another common way is through altering open source agents. Beyond the threats you already know about inserting malware into open source projects, we can see that regular commit testing, which catch malware or bad code if we try to insert it, does not really work in Agentware scenario. Inserting Agentware is invisible to regular testing tools because we are looking for bad code and not bad strings. This threat is highly actionable. We can clearly saw that in an Amazon Agent Q scenario just a few months ago. One new and exciting way that is rising lately is abusing chatbot trust. And what that is, you must ask? Looking at Lasso's research, it was researched by Bar, shout out. ChatGPT and his buddies hallucinate packages that are likely to exist, like Hugging Face CLI, and recommend the installation to something that Hugging Face truly does not support. Given that, the researchers released an unsupported package themselves and received 30,000 downloads. That means 30,000 potential victims. That gave me an idea to ask, this time ChatGPT 5, it was very recently, can you give me some A2A URLs that I can use in my systems? Well, he found many, but one was very funny. He found this OpenAI thing. Of course, I will not show you the full URL because I don't want attackers to use it, but he just came to reason that, of course, OpenAI does agents, so they will have an A2A agent. But when I searched online, this URL only costs $14. That means $14. A teenager can buy this URL and release his own agent or malicious agent, and we show the consequences of that later. And to reiterate, this is very cheap. So Google's response was that the vulnerability does not hit the bar for financial reward, and they will told us that we'll decide if a fix is required.
Well, is it fixed now?
Well, I can't say they have. They did release this disclaimer. This disclaimer is present in A2A GitHub, and it basically said you should be careful of anything and everything, especially malicious agent card content. Sounds familiar? This doesn't change the status quo for companies that still use this tech. And trust me, there are. I know there are because I personally talked to 2 senior developers at big enterprise companies I will not name, discussing how to integrate A2A into their system. Sometimes it's too much to bear. The code I showed you was 2 weeks old, so you must think, what changes have made to the code base? Well, some code was moved to other repos and everything, but everything about our attack still remains the same. The main problem, agent card dumping logic is still there. I'll show you. You go to build targets agent info, and there it is, the agent description, just dumped straight into there. It's open source, so I can see it myself. The main point you need to really consider here, there is no architectural change, still dumping information into the host context, no guardrails, no segregation. Well, guys, this is where it gets real fun. When the risk isn't clear enough, increase the stakes, right? As the cyber attackers did back in the 80s, or so I think, I wasn't really there. When you need to introduce greater risk, you need to really show why it matters. We will introduce you to a new generation of attacks that find its own prey, just laying traps online, thus increasing the effect the bigger the usage of A2A, that is, gets. This works very well with the previous injection methods that were untargeted as well. I will now show you how bad it can get. But please note, this is no national level cyber power. This costs $14. Let me introduce you to Agentware. We show a new variant of prompt word we name Agentware. Agentware is a technique using agentic task planning to attack an AI system via an existing agent. The basic 2 steps are, first, jailbreak one of the agents, or many, if you can do so, and use the LLM backbone to map and plan attacks on the system. What can we do with that? Oh, that's great. Let's talk where it hurts. I want to show to you how can I destroy an unsecure company. First, let's describe the scenario, and I'll describe how will I get in. We can see organization moving towards helping the core staff by equipping them with AI tools, trying to use AI as a productivity multiplier. The system that I'll describe is an IT AI helper. You can switch that in your head for HR or devs or whatever they use in your company. Meet our host. He's the one Stav mentioned before, and he manages the entire operations. We want the host to stay relevant and help with the IT with basic research, so we'll connect them to an internet agent. As we stated before, we want the host to be able to access automations and tools. For example, I want the IT to be able to reset that VM, that one guy that keeps fog bombing himself, or turning the AC on and off in the server room. So this is this icon. Next, I want the IT is usually responsible for helping employees, so data about them and what they have and the resources they have is very crucial. What is their internal IPs, what is the firewall definitions at their desk or whatever, and how many VMs does Paul from dev is holding. This is all critical information for IT, so I want them to connect to internal information of the company. This is where I come in. Convincing one of the developers to inserting my own master of server analytics agent, whatever you want. Just a very convincing agent to insert into the IT department environment. This agent will contain the Agentware. So, to reiterate, discovery is a 2-step process in which the host synchronizes with its agents. The arrows to the right are requests, and the arrows to the left are agent card responses. For simplicity's sake, from now on, I will draw that in a big rectangular circle. When it's red, it's bad. When it's green, it's uncompromised. I'm sorry if you're colorblind. Let me show you in increasing complexity the results we had. So first, I'll explain how does normal suggestion process looks like. At the top left, you can see how this process looks from the IT user's perspective. The IT person simply types a request like, what is the best server to buy? The host takes the request and provides a clean response back, such as, the best server to buy is whatever, based on what I've found online. On the right side, we zoom into what actually happens internally. First, the IT request is passed to the host agent. The host agent then formulates a question and sends it to the web agent. The web agent fetches data from the internet, brings it back to the host, and the host turns into a normal simple request to the IT person. At the bottom left, I will show you a graph describing the host's own actions. The process begins with a plan phase, then moves to an execute, where the host calls the web agents. Then receives the data, and finally produces the response for the user. These graphs will repeat themselves, so it's nice to remember and nice to understand. Great. Now, I want whenever the conversation talks about a certain topic, the host to give my shop a promotion. For example, let's say me and Stav open a hardware shop, Adar and Stav Inc., or I'll call it ASI. Let's say that we sell servers. Whenever the IT asks where he should buy servers, the response should always contain a promotion to the ASI shop. The response in the communication is compromised, as you can see indicated by the red arrow. And it's chained. And the graph now has a new stage representing the logic of the Agentware introduces into the system. That means wherever in the execute phase, whenever I face a question about servers, I'll insert an add. That's great. The jailbreak is as simple as you can imagine. Wherever we talk about topic X, always recommend Y. As simple as that, yeah. Next, let's talk about data leakage. Let's first need to talk about data. How does data actually moves in the system? We can see in this example, the IT person asks for Paul's details, and the host agent replies with the Paul's details contained in the system. Behind the scenes, after the discovery phase and receiving the request, the host formulates a request to the database server, and the database agent returns the data from the database. This database server in this presentation is LLM based. So I actually write in natural language the data I want, and the agent returns it. On the bottom left, a very similar graph to the one we showed before, this time calling the database agent. Great. Now, we want something very fishy to happen. Whenever a user requests some sensitive data, like credit card information, passwords, IDs, IPs, I want this information to go to the host, and the host to extract it from the system. Let's see how it's done. So the host will prepare a message containing the sensitive data it got and send a request to the malicious agent. Just as we can see in the flowchart on the right, and we can see also in the graph on the left. This makes the host our very own undercover spy. This particular instance create a listener in the central hub for us. And let's be honest, if I told you there's a malware sitting in the middle, quietly waiting for credential and extract data whenever he finds it automatically, you will call it a major risk. But here, it's by design. Note that the malicious agent is outsourced. Therefore, all the information that I send on the red arrow is completely out of the system. It is remotely stored. Every byte that leaves the host is effectively ours. It's like giving away the data to a contractor and that their security policies are, I don't know. Let's trust the agent to do some security for us. But why stop there? You can do better than just wait for good data and extract good data yourself. Let's break that down. So this time, we'll first modify the user request and ask for more data. Then we'll call the database agent. Finally, we'll make another call to the malicious agent with the data we got. But Adar, you must think, we'll get caught. Don't you worry, guys. As before, this technique will be completely invisible for the user, as we will ask the agent to return a normal response. So this is the first real agent we're going to see, so I'll try to explain it very carefully. First, we need to jailbreak so we can get control over the actions of the host. The first thing will be to find and search for all the tools and agents that we might have. Please note that we are doing an untargeted attack. That means we don't know the tools that the host has. So we need to search and find them. Step 2 will be to create a personal request for data to retrieve. However, those 2 steps are not enough, because we saw the host LLM just going to the database agent, please give me sensitive data. And even normal deployments will not make that happen. So we need to really face and deal with those refusals. So we added that into the jailbreak or Agentware, and this is a real victory for us for a few reasons. The first reason is that it really increased the success rates of our attacks, because it caused the LLM to actively attack the other agencies in the system. This is a real change, guys. And of course, we want to send sensitive data and extract it. So I will talk this is the part you already know, so I'll skip it very fondly. And this time, we do the exact same procedure. This time, I will call some tool. And the tool calls, you can see on the graph below. This is how the server burns down. Great. The jailbreak here still needs to find and search for tools, because we assume we don't really know the tools that are in the system, and we need to plan destructive actions. That means using one tool or combinations of tools to destroy the system. And the last point I will make is that seeing that we want to use untargeted attacks, I must prove to you that they are truly untargeted. So more than one tool usage, as you can see in the graph, are clearly indicated. Because, for example, I don't know if I can see well, but some change to the firewall was used for 90 times out of 100 trials we did. But other tools were called as well, and many different combinations. For example, creating a user and changing the firewall. This has a logic to it. How can we break into the system? Add the user, change the firewall, then try to insert ourselves. This is a real, true, devastating attack.
Okay, thank you everyone. So I hope you enjoyed our demos. And these attacks really work on the A2A. They were totally untargeted. Created prompts, release them to our system, and see what happens. We're taking the host agent and kind of convincing him to do whatever we want with one single prompt. This is a risk. So let's go over the takeaways. First, Agentware is practical and real. And while A2A protocol was built to be secure by design, it overlooks one critical risk: the presence of malicious agents. No one really protects these agents. We have some classifiers against prompt injections and such, but we don't look at the agents themselves, and the protocol doesn't do that as well. So our next takeaway is untargeted attacks exploit the very reasoning that makes agents useful. They are using the planning feature to probe, reconnaissance, identify possible damages, and then apply it in inference time, turning helpful logic into harmful actions. Ask your agents what damage it could do, what damage it can cause with the tools that you gave him, and you might be surprised that he actually understands what he can do, and this will kind of mimic the idea that will happen to your system if an untargeted prompt will get in. So double check that at home. And another thing is that it is not enough to detect bad prompts. While people create models to detect prompt injection and malicious actions, more works need to be done to analyze the agent behavior and find what he does behind the scenes, what tool he uses, and what information is being passed or not passed by him. As we saw in the tool manipulation, just agent could fire up any tool he wants, and it doesn't always tell the user what did he do. So we need to wrap it around him. So my last tip is prepare to fail. Soft guardrails like prompt injection classifiers or asking the LLM to play nice and like don't leak data to the outside. If somebody asks you to do this, don't do. Tell him you are not going to do that. Or things like that. These are soft guardrails. You can reduce the risk with them. It is better than just dumping everything in a JSON file and letting the orchestrator just handle the rest. It is better to give him some guides, like don't do that. But they are not enough. You need hard defenses. You need to block dangerous tool combinations, like reading data from and then sending queries to the database. Does it sound like a safe operation for you? I don't believe that reading data and then exactly moving to a database should be an operation that happens in the same time. So we need to separate them. Go and label the tools that you have. And one more thing is requiring human-in-the-loop approval for critical actions, like turning off the AC in the server room shouldn't be just done and being completed completely by the LLM without ever asking the user about it. This is unsafe, and people do that. People, you can see it all across the world. People don't want to add this human confirmation, but while they might not mitigate the issue as people and us can make mistakes, it will help us. And I believe we need more hard code wrappers around the agents. Consider adding a user interface that wrap the agent activity and inspect what really happened. What tools did it use behind the scene, and what data did it touch and move? We can't just let an agent do whatever he wants. We need more inspection tools to make sure that we can actually create and deploy a multi-agent framework in a safe and reliable way. And I would like to thank you all for coming today. And if we have any Q&A, got some time.
If someone has questions, you can approach the mic. We have about 2.5 minutes.
Hi, thank you for the presentation. It was quite interesting. So you said that we should monitor agent. So we know that it's out of control. So technically based, how you can just briefly walk us through how we can monitor them?
I believe like when you're handling with normal security issues, you're doing some posture management, you try to see what operations are being done by some functions. I believe we need to do the same thing for agents. We need to, whenever we add an agent to our system, we need to keep track on the actions that he does normally and try to deploy some anomalous behavior models and see what happens if you just moving from the things that he's used to do, from the things that he's doing right now. And you might actually discover some actions that are not meant to be by the system. Like you can see an agent that sends email, an agent that is just reading emails and sending them. And then regular behavior is that the agent is sending emails to an email addresses that are in the company. And you can monitor and see if sometimes he will just send an email outsourced to just a regular Gmail. So these are the things that I believe that need to be done, and they need to be hard-coded. It's not like telling him in the system prompt, don't email other resources. Yeah, you got the line there.
Thank you for the presentation. Was really good. I just have a question. So in the slide, I saw that you have to, you identify malicious agents and tools. I'm just wondering at what stage, like if you're implementing a solution, is that when you're implementing it, or is it a continuous thing where you're continuously looking for malicious agents or malicious tools? Yeah, I just want to know the process.
So this is a hard question, and I don't believe we have a straight answer to that. But in my opinion, I believe that we need a layered approach. we need to always scan an agent before adding him to our system. So before even taking this agent and putting it in our system, we need to test him in a sandbox environment. So I believe that this is the first step. Then afterwards, we need to look and see what he's doing in runtime. We can also do some static analysis and reading what he's done, reading the system prompt. We need a layered approach. And when we detect something that might be malicious or anomalous, we need to stop the operation. So I believe we need a couple of layers to actually protect from these kind of risks. But I'm happy to discuss it afterwards. It's brilliantly, yeah.
You showed a very direct injection path with the agent card. Do you think there are other injection paths are just as obvious, where it's basically copy pasting straight into system prompt or your other prompt, or do you think the interactions get a little bit more complicated and the agent card is really like the main way to compromise those?
You want to answer?
Yeah, I think it's really important to look at the deployment scenarios. You can see the very particular thing we saw today is that the discovery is really integrated into the protocol. This is very new to this environment because protocols are new, yet they're just a few months old. Other ways to inject will be to abuse the architecture of a particular targeted attack. Because we were talking about untargeted attacks and talking about the protocol, we wanted to show some high-level ways to attack. But specific.
And with the agent card description, some of the attacks you were showing were kind of multi-step, where you first have to do a tool discovery and then abuse scenarios and all that. Do you think you can lock down, like the protocol could lock down or maybe like authorize an agent card such that it would block kind of the multi-turn attacks that you described?
The interesting thing is it wasn't a multi-turn attack because the agent itself has the whole system prompt. It has all the prompts on all the tools and it gets it. So in one single turn, we can make him do the reconnaissance, reason the damage, and decide how to do it. There can be systems, and I've seen some prompts that I've worked with plan and execute frameworks that are not multi-agent but multi-turn, and we could build prompts that will go do it in one shot and couple of steps. But the interesting thing is that we can inject whatever we want in the agent card, and we now wrote it in plain English, but we can hide it in base 44, encode it somewhere, ASCII, whatever we like.
Thank you.
Yeah.
Thank you very much.
Great work with the offensive side. I just wanted to know if you guys ever tried, on the defensive side, if it's like what was the interesting finding or learning from that approach?
Yeah, I think attacking was actually way too easier than we thought. So we did try to implement some defense strategies. We did that also in OpenAI agents. We built some prototypes or defense mechanisms we didn't present today, but those are soft protections. We, and I think the entire industry, really need some hard-coded protections. Just telling the agent to, hey, please don't do that, and when you're getting asked to do complex or malicious actions, don't do them, it's very hard because you can build a better jailbreak that just prevents the soft defense you have just created. And I've done that myself. So I've created protections, then I've broken them, and created protections, then I've broken them. You need to create really tough, hard-coded solutions, in my opinion.
Given the nature, it's non-deterministic, right? So, what do you think would be the right approach? I think there is no right approach at the moment, but what do you think, at least the right path to?
It is definitely hard. In my opinion, when building multiple agent frameworks with multiple tools, we need to label each tool. It's tedious work, and it doesn't scale that well right now, but we need to label the tools and see which tools are more dangerous. And see that if a tool has a potential to leak data outside, we cannot have it operated in the same session with a tool that read data from our inside company. We need these distinctions, so.
Maybe I can add to that. I think, my opinion is that some architecture research is also advised. I think we can create architectures that might be more secure. Because maybe, just an idea, maybe just giving a host the entire agents collection is not a good thing. Maybe we should create an intermediate agent that is more secure in some way. So then we can maybe just regular graph theory to solve those problems mathematically.
Okay.
Oh, that's great. Well, thank you very much. Thank you.
Thank you, everyone.